All right, so we're going to go ahead and do example 1 of vectored valued functions. So let r of t, the vector for position, be in the x direction t squared minus 2t plus 3, and in the y direction t cubed minus 3t. First thing we're going to do is find the particle's velocity at t equals 2. Now that's a bit of a trick question because you can't just find the velocity at 2, you have to find the velocity vector and then plug in t equals 2. So when we go to do part A, for part A, my velocity vector should be what happens if I derive the x vector, so that's 2t minus 2, right? And then the y vector, which is a 3t squared minus 3, right? So that's my velocity vector all the time, which means my velocity vector at 2 should be a 4 minus 2, comma, a 12 minus 3. So my velocity vector at 2 is a 2 in the x direction and a 9 in the y direction, and that's my answer to part A. For part B, I'm asked to find the acceleration vector, which means I'm going to derive my velocity vector. So my A vector is going to be the derivative of this guy, which is just a 2, and the derivative of this guy, which is a 6t. So that's my acceleration vector. Again, I think it's the notation that bogs us down most of the time. These problems actually aren't all that terrible. The last bit, part C, requires that you know what the words at rest mean. So remember, at rest means that both my x motion, right, my x velocity and my y velocity are 0, right? So if I set both my x velocity equals 0, so if my x prime of t, right, which is 2t minus 2 is equal to 0, then I get that t is 1 is the only possible answer. I need my y prime of t to also be equal to 0, so I set 3t squared minus 3 equal to 0. I get t squared equals 1, so I get t is plus or minus 1. Since I got only t equals 1 for the x direction, and I got both plus or minus 1 for the y direction, my final answer is going to have to be only t equals 1. So my answer to C is t equals 1 only.